All right, so let's have a look at this question. So now here we're also looking at a similarity type of question, but the main thing about this one, it is to get into 14.3. Notice that 14.3, it is a different question, right? But they still want you to prove, so which means different question require a different approach, right? So if you've watched my previous video, we did a question like this, and then we had its own investigation and approach. So which means this one will have the same thing. So before we get into that 14.3 though, I will still need to go through the whole process of analyzing the question, starting from finding the angles, ratios, and then from there answering 14.1, 14.2, and 14.3, right? But then that doesn't mean that if you already understand how to find all the ratios and angles, that you can't jump to 14.3. The video already has been set in a way that you can basically jump into whichever question you want to jump into. All right, so without wasting any further time, I'm just going to go straight into the first step. So the first step that we're going to be doing, of course, is reading through the instruction and finding the angles that we're given there. All right, so now here the instruction goes as follows. In the diagram alongside, PWUT is a cyclic quadrilateral with WU equals to TU. Chords WT and PU intersect at Q. PW is extended to S such that US is parallel to TW. All right. So the first thing, of course, that we're going to do, because we're looking into a similarity type of question, we're going to first look for ratios, right? Now, the reason why I'm pointing out that we need to look for ratios is because I can see that there's triangle here, SPU. So in triangle SPU, let me just write it there. Triangle SPU there, I can take out proportionality there. So I can see that here, I can say PW over SW equals to PQ over QU. So that's one way I can do this. Or I can take PW over PS or SP. Let me just write it as PS. I can say this is the same as PQ over PU. Or I can say SW over PS is equals to QU over PU, right? So that is basically what I get from this triangle at the top. It's either this with that, or it is this with that, of course, in proportion with the other side, right? Or this with that. So that's basically what I just did there. And then on the next thing to do, basically, we're still in the first part. Next thing to do is to find the angles, right? So with the angles here, we'll be using Dr. Cape Town, so I'm going to write it as DR CPT. Now, according to the instructions that we're given, I know that we have cyclic quad, so I'm going to underline that. And also, there was some extra info that we were given there. There were lines that were equal, so I'm going to also highlight that. And also, we were given parallel lines. So we were not given diameter, we were not given center, and we're also not given tangent, right? Now, this is very important because the reason why I'm saying this is because sometimes you will notice that in the diagram, you see something like a tangent, but then here it was not mentioned that it was a tangent. But then now you'll see questions like this one, for example, here, I'm asking you to prove that it is a tangent, you know. So one thing that I would say about this is that when you encounter such questions, please make sure that when you look into the diagram, just write it as it is, right? And then if you come across into a part where it asks, where it wants you to prove that, you just need to make sure that you prove that, right? But in this one, I'm not going to put that. I'm just going to pretend as if there's no tangent because it was not mentioned there. So which means here, I will say I don't have a diameter, I don't have a radius, I don't have a tangent, but I do have cyclic quad and parallel lines because that's what has been mentioned into the statement. Most of the time, the statement is much more stronger than the diagram. But if there's no statement, then of course the diagram is the one that is much more stronger. All right. So let's go ahead and look into cyclic quad. So in the cyclic quad, I do see two opposite interior angles. So those will be W1 plus W2 plus T1 plus T2 adding up to 180. and then I have P1 plus P2 plus U2 plus U3 adding up to 180. And the second part, I have exterior of the cyclic quad, so this will be W3 equals to T1 plus T2. And then thirdly, I have angles on same segment. So angles on the same segment is W1 equals to U3. It is T1 equals to P2. It is W2 equals to P1. And then it is U2 equals to T2. All right, so those are the ones that I find under the cyclic quad. And then I'm going to move into the parallel lines. So in the parallel lines, let me rather use US parallel to TW, of course. So with that, I'm looking for corresponding angles. So I'm going to put corresponding angles. So here, W1, of course, it is angle S, right? And then from there, I see Q2 with U1 plus U2. And then I see Q3 with U3 plus U4. Okay, and from here, I see a co-interior. So the co-interior will be W2 plus W3 plus S, adding to 180. And then it will be Q1 plus U2 plus U1, or U1 plus U2 equals to 180. And then it will be Q4 with U3 plus U4 adding to 180. All right. And then I have the last part, which is alternate angles. So the alternate angles, I have this line first that alternates there. So which means U1, it is W2. Take that line out. I have this second line here. So U1 plus U2 is equals to Q4. And then the other way around, U3 plus U4 is equals to Q1. And then from there, I have this line here. So in this line here, what do I have? I have U4 equals to T1. Okay. And then from here, if you remember, we were told that WU is equal to TU, right? So WU is equal to TU. Okay, so what does that mean? So WU equals to TU. So if this is the case, then this basically means now that there's either an isosceles triangle there, or there's two angles that are separated, right? Both touching into a circle, and then they just gonna have equal angles. So for example, in this case, we're saying this is equal to that. So let me just put it in black to show that this is what we're given. So because of that, this means that this angle is the same as this angle, right? So I'm gonna say T1, or rather, let me just open a new space, put it in a different space. So we're saying WU equals to TU. So this means I see the base angles of an isosceles. So T1 is equal to W2. And another thing that I see here, it is the corollary, right? So it means equal angles, equal sides, equal angles at the circumference, right? You can see if this is equal to that, then it means this is equal to that, right? So I'm going to write it as equal sides, equal angles. So that will then be P1 equals to P2. Okay, so I have everything that I need now. So I'm going to go into the next part, which is to answer the question. So let's go ahead and look into how we can answer the questions. The first question here says that we need to prove that US is a tangent to a circle PWUT at U. All right. So now here we need to prove that SU or US is a tangent. So how do we prove that this is a tangent? Okay. So to prove that something is a tangent, right, we need to assume that it is already a tangent. So if I'm assuming, what I'm going to do is I'm going to draw this line as a tangent. I'm going to look at it as a tangent, and I'm going to ask myself, what can I then conclude about this? So what I can conclude about this is that if this is a tangent, then I either have this triangle to prove, right? I have that triangle to prove. So what would I do, or what would I be proving here? So basically what I will be proving is that this angle is equal to that, or this angle is equal to that, right? So that is one way that you can do, right? So I'm going to break it down so that I can do it step by step so that it doesn't confuse, right? So now here, this is the first part that I can do to prove that this is true. So now what I'm going to do here is I'm going to ask myself, is there a way where I can basically prove that this is true, right? So a way will then be me wondering if I can, I do have U1 and then T1 in my instructions, right? So here I'm going to first look at the U1. So I'm going to go over there and then see where do I see U1. Okay, so I see U1 here, and then I'm told that U1 is equal to W2, right? So I'm going to mark that, right? And then from there, I've found U1, which is fine. Then now I need to find what? I need to find T1, right? Now remember, in order for this to be true, T1 must also be W2, right? So I only found one U1, so that is fine. And then now I'm looking for T1. So T1 is that. And there's also T1 there. Now look at this T1 here. This T1 is equal to W2. So it means if I want to prove this is a tangent, then I just need to say that U1, find U1, what's the value for U1, and then prove T1, and then from there I've found my answer. So which means now what I need to show here that is true, I need to show that U1 is the same as T1. Now how do I do that? So this is what I do. I remember that we said that U1 is equal to W2. Now, part of the reason why that was here was that it was alternate angles, right? So I'm going to write that alternate angles equal where US parallel to TW. And then from there, I will say now T1. I know that T1 is also equals to W2, and then this is equals to base angles. This is base angles of isosceles triangle UTW, of course, where WU is equals to UT. Okay, now this basically means now U1 is T1, and so US is tangent. Now the reason for this is because we've proven 10 chord here, so we ended up using these angles. So we've proven 10 chord here, but then now because of that was not a tangent at that time, we're gonna write it as converse, right? So I'm gonna use it as converse 10 chord. So by converse, it means it's some sort of like a reverse, right? Okay, so now that I've proven that, I'm gonna go into the next question. So let's go ahead and look into the next question. All right, so in the second question here, they want us to prove that 14.2 triangle SPW is similar to triangle SUW. All right, so usually most of the time when you're given this, right, it basically, this is like a hint, right? So it's a hint that this angle, you need to come up with a reason as to why this angle is equal to that, and why this angle is equal to that, and why this angle is equals to that one, right? Now, what's the first thing that we're going to do here? So the first thing I'm going to do is I'm going to need to ask myself, what is SPU, right? So SPU in this case here, I can see that angle S, it is angle S, but then angle P here is P2, but angle U, it is U1 plus U2, right? Now, this is similar to triangle. Now, SUW, so angle S there is S, and then angle U there is U1. and then from there I have u1, and then w, it is w3. All right, so okay, so right now, like I said, I just need to see if this is equal to that, and this is equal to that, and this is equal to that, and why that is. Okay, so now from here, first things first, I can see that angle S and angle S are common, so which means I'm going to write angle S is equal to angle S, and this is common. And then from here, or common angle, let me just write it, common angle. And then from here, what I'm going to do is I'm going to check a reason why P2 is equal to U1. Now, how do I do that? So basically, what I do is you go back into what you were given and then find the reason why this is true. Okay, so now basically from here, what I see, actually, I don't even think that I need to go back. What I see here is that with P2, right, I can see that P2 is the same as U1, and the reason for that is basically the 10 chord theorem, right? So because of I have proven that, so I can then say here P2, right, is the same as U1, and that is 10 chord theorem. Okay, and then because of that, then this then means that U1 plus U2 is equals to W3, and the reason for that will just be third angle. Now the nice thing about this is just you need to prove two angles here. Once you find two angles, then the rest is just a wrap. So now here we then see that therefore triangle SPU is similar to triangle SUW. And then the reason for that it is angle, angle, angle. Now the nice thing about this is that once you prove that they are similar, then this basically means that the ratios are in proportion. So this over that is the same as that over that, and this over that. All right, so now we're going to be going to the moment that we've been waiting for, which is 14.3, and that is to try and find out or discover a method or an approach to simplify or to prove similarity that it is in this structure. So here we have SU squared times QU equals to PU times SW squared. Okay, now part of the investigation, in order for us to investigate everything, we must first make sure that we write everything that we got when it comes to ratios. So if you remember, we had the ratios that we wrote. We said this over that, and then we said this and that, and then we said this and that. So I'm going to go ahead and write all of that, and then we're going to continue from there. All right, so basically I copied everything that we had earlier on the information about ratios, and so now the next thing that I'm going to do is to copy everything that we get the ratios on the similarity. Okay, so note that every time when you do this, right, always make sure that every sign that you see there is the same thing. For example, if I see PS here, I must see PS everywhere. PW must be the same thing. PQ, same thing. SW, I see SW everywhere. QU, see QU. PU, same thing, and all of that, right? Just make sure that they correspond. All right, so now let's go ahead and look into the investigation. So the investigation here, it is about understanding where this thing came from. So I'm going to write investigation here. Now, before we even do the investigation, what's the first thing that we need to do? First thing that you must do is you must mark all the sides that you see here. For example, SU. So I must mark all the SUs that I see there. And then QU, you must mark all the QUs. QU there. PU, I'm just going to mark PU. And then SW, I'll mark SW there. Okay, so now we're going to start with the first investigation. I see SW there, didn't mark it. PU. All right, so our first investigation basically will be us taking this taking these squared together and then this together, right? So I will say, okay, here I have SU over SW. Now notice that I'm going to put the square out there because it it's easy for me to see it when it's like that. So I'm just gonna put it like that, and I'm gonna say PU over QU. All right. So now from here, after doing this, I'm just gonna see if I do have PU over QU. Okay. So now looking at this, I do see that I have PU over QU. So where do I find PU over QU? Here, but it's written the other way around, right? So basically, instead of having it as PU over QU, they had it as QU over PU. So let me go ahead and just change this, and we're still doing the same thing, but I'm just going to write it as QU over PU since I see that. So to do that, I'm taking this PU to this side. So I had QU here over PU. So this means now I'm taking the SU to the other side. So SW over SU. Or let me just give it a squared now because it's the same thing. It doesn't matter which way. So now here, I can see here that, okay, here, this is probably my start because now I have QU over PU, but then I can see that it is the same as SW. Then now the next thing is, where do I find PS, right? So now to find PS, we'll then see where is PS. All right, so PS basically, it is here. I can't use this one because I'm already going to use this one and the, okay. Now looking at this, I can see that this PS, if I solve it, if I simplify it, I can get SU squared. I can get SU squared here, and then it will give me SW. So this SW will probably multiply with this one. So what does this mean then? So this means now from here, I'm going to put that into action. So how do I put it into action? So basically, I'll start with what I have here by saying QU over PU, but then of course I know this is equals to what now? So QU over PU, I know it is equals to SW over PS, right? So the reason for this, it is basically prop theorem. All right. So now from here, I can see that I need to find PS, like I said, right? So therefore, having this, I will then say PS over SU. This is equals to SU over SW. Notice that I used the sides that I needed from that. So this is the prop sides of similar triangles. Okay, so having that, what does this mean now? So basically, this means now from here I can cross multiply this SUD, and then I'll be left with PS as SU times SU will be SU squared over, and then I'll have SW. So I'll say SW. Then I'll then go back to QU over PU, and then here QU over PU. Remember we said it was SW over PS. And then now what I'm going to do here is I'm going to substitute the value for PS, right? Or rather, let me cross multiply first because I don't want this to confuse. So I'm going to cross multiply first. So it will be QU times PS equals to SW times PU. And then I know the value for PS, it is SU squared over SW. Now this is SW times PU. Then I'll take this SW and multiply there. So QU times SU squared will then be SW squared times PU. And that is that answer actually. So therefore SU squared times QU is equals to PU times SW squared. All right. Now that we got the answer, what does this mean? So this means now when it comes to similarity, because similarity is more challenging, this means now the minute you see something of this manner, right? The minute you see something of this manner or something of this manner also, actually, because most of the time you will always find them in this manner, right? So this means now the first thing that you need to check here, there should be proportionality, right? There should be proportionality because that's what we started with here. We start with the prop theorem, and then from there you need to apply the similarity, because there you will find one side, so you apply the similarity exactly how we did it there, because it doesn't change. The only thing that changes is the question, but the minute the only thing that changes is the structure and the diagram. Structure is still the same, diagram changes, but then now this means the minute you see something of this manner, then this is how you apply it. And that's it for this video. Please make sure you don't forget to share this with your friends, and then like it and leave a comment and tell me what do you think about this video. Did you enjoy it? Did I explain more? Do you want me to try and do more others? This way will basically help me to make sure that I prepare everything that that you will need towards your June exams or your supplementary exams. And that's it for this video, and I'm gonna see you on to the next one. Cheers.